Hello everyone, in this video I'll be talking about the nomenclature of alkanes, and we will discuss simple alkanes as well as alkenes, maybe some cyclic compounds as well. Okay, so naming hydrocarbons are alkanes, alkenes and alkynes. Hydrocarbon means they are all made up of carbon and hydrogen. So hydrocarbon means they are made up of C and H. That's why they are called hydrocarbons. And there are three types of hydrocarbons in organic chemistry. One is alkane, which contains single bond, and it is sp3 hybridized in nature. So one is alkane, another is alkene, and another is alkyne. So alkane is a single bond, alkene is a double bond, and alkyne is a triple bond. So these are the three types of hydrocarbons. One is alkane, and second is this double bond. This is alkene, and third one is the alkyne. So organic compounds are any covalently bonded compounds containing carbon, except you have to put the question marks, answer of the question marks in the blanks. So hydrocarbons, organic compounds that contain only carbon and hydrogen, are called hydrocarbons. Hydrocarbons contain only single covalent bonds, that is alkanes. Contain one or more double bond, that is alkenes, and contain one or more triple bond, that is alkynes. So these are the three types of hydrocarbons: alkane, alkene and alkyne. We will be discussing their nomenclature. So saturated and unsaturated hydrocarbons. So saturated are alkanes because they contain single bond, and unsaturated are alkenes and alkynes because they contain double and triple bond. Saturated hydrocarbons contain only single bond carbon-carbon bonds. Unsaturated carbons contain double bond carbon-carbon chains or triple carbon bond chains. If there is a triple bond, that is alkyne. If there is double bond, that is alkene. If there is a single bond, that is alkane. So there is a degree of unsaturation in alkenes and alkynes, but in alkane there is no degree of unsaturation. So these are the general formula of alkane: CnH2n plus 2. So where n is any number, it could be 1 or it could be up to 10 or up to 100. So this is the n, so you put the value of n 1 or 2, then you will make the members of alkane. And this is the general formula of alkene: CnH2n. Again, n is equals to any number. Then the general formula of alkyne: CnH2n minus 2. Then n is again equals to this. So the hybridization of alkanes is sp3, keep in mind, and the hybridization of alkenes is sp2, and the hybridization of alkynes is sp hybridized. Okay, let's move on. So here we will be, you should note down these basic terminology. So if there is one carbon atoms, we call it meth. If there are two carbons, we call it eth. If there are three carbons, we call it prop. If there are four carbons, but. If there are five carbons, they are pent. If there are six carbons, that is hex. If there is seven carbons, hept. If there are 8, oct. If there are 9, then 9. If there are dec, there is 10. Must memorize prefixes to name. Look at the formula for the hydrocarbon. Determine if it is an alkane, alkene or alkyne. Use the prefix for the number of carbons, adding n for alkane, en for alkenes, and yene for alkynes. So these are the prefixes that one should remember in order to be good at nomenclatures. So if there is one carbon, we call it meth. If there are two carbons, we call it eth, and accordingly we add it. So if there is one carbon, we call it methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and then this is decane. Similarly, methane, and there cannot be methane. The alkenes start from number 2 carbon, as there should be a double bond between carbon and carbon. So this is ethene, propene, butene, pentene, hexane, heptane, octane, and nonane, and decane. That's decane. Similarly for alkynes, so alkynes also start from carbon 2, ethine, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. If you are asked what will be the name of this compound, you should first write the name, first 4 prefixes: meth for 1 carbon, eth for 2 carbons, prop for 3 carbons, and but for 4 carbons. Monkeys eat peeled bananas. So you have to remember like this. Monkeys eat peeled bananas. Methane, ethane, propane, butane. Numbering carbons. Draw pentene. Name these. So if you are asked to name this compound, so you have to numbering 1, 2, 3, and 4. So the name of this compound will be, as there are 4 carbons, we will call it but, but, and we will give dash, and there is a double bond at position 2. We will say 2, and we will put ene at the end. ene, butene. About this 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 9 carbons. We will call it non, and there's a triple bond. We will put the position of triple bond 3, and we will add y, n, e, non 3 wine. That will be the name of the compound. So non because there are 9 carbons, 3 because there is a triple bond at position 3, wine because there is a triple bond. If there are more than 2 bonds, I think this structure is wrong. If you look at this one is right. So you count numbering from this side: 1, 2, 3, 4, 5, 6, 7, 8, 9. Then name of compound will be non because there are 9 carbons, non, dash, there's a triple bond at 2, we will write 2, there's a triple bond at 4, we will write comma 4, there's a triple bond at 6, we will write comma 6, and tri because of 3 triple bonds, tri, and there's a triple bond, that's why we will call YNE. Non 246 triwine. 246 non triwine. Give first bond point of difference lowest. Include di, tri, tetra, penta, etc. before enwine. Common, comma between hyphen between letter. You don't need to know ENE plus YN. So 2-butane, 1,4-pentatriene. Why? Because this is 1, 2, 3, 4 and 5. So there's a double bond at 1, there's double bond at 2, and there's double bond at position 4. That's why 1 to 4, because there are 3 double bonds. There are 5 carbons, we are calling it 5-penta, and due to 3 double bonds we call it tri, and there are double bonds, that's why we call it ene. 1 to 4 pentatriene. And there is 1,2-hexadiene. Cyclic structures. Cyclic structures are circular, have cyclo in name, like this one, cyclopentane. Draw these. Note carbons in a double bond should be consecutive, 1, 2, 5 and 6. Cyclobutene, 1, 3 cyclopentadiene, cyclopropane. So this is cyclobutene, this one. As you can see that there are 4 carbons in a cyclic nature, 1, 2, 3 and 4, and there's a double bond inside the cycle. That is why we are adding E and E at the name cyclobutene. Then we have 1,3-cyclopentadiene. As you can see, this is a 1,3-cyclopentadiene. This is carbon 1, this is carbon 2, this is carbon 3, and this is 4, and this one is 5. So there's a double bond at position 1, there's a double bond at position 3, and there are 5 carbons total in a ring. So 1,3-cyclopentadiene. There are 2 double bonds, that's why we are calling it pentadiene. Then we have a cyclopropane. As you can see, the name ends at ANE. That means it's an alkane having no double bond. Naming side chains. Names are made up of side chains, root. Like this is a compound. So 2,4,2,3-dimethylpentane will be the name. So we will start numbering from this position: 1, 2, 3, 4 and 5. So the red line is the parent chain, that is called root, and these are called substituents or side chain. So this methyl is a substituent, and this methyl is also substituent or side chain. So methyl is present at 2 and methyl is present at 3, and so we call it 2,3-dimethylpentane. Root is the longest possible hydrocarbon chain. Must contain multiple bonds if present. Add YL to get name of side chain, like methyl. So end name is YL to get name of side chain. Common side chains include methyl, ethyl, propyl, butyl, isopropyl. Chloro, fluoro, bromo, iodo. These are the common sides. Naming side chain. Name the following structure. So we will start numbering from 1 to 3. Choose the correct ending. Where should it end? ENE. It should end at ENE because there is double bond. Then choose the rule number 2, longest carbon chain. That should be the longest carbon chain. Rule number 3, attach prefix according to number of carbons. 1 hexane, because this is 1 carbon, this is 2, this is 3, this is 4, this is 5, and this is 6. Assign numbers to each carbon. 1, 2, 3, 4, 5, 6. Determine name for side chains. Ethyl, methyl, methyl. So there are 3 side chains, 2 methyls and 1 ethyl. Rule number 6, attach name of branches. 2 ethyl, 4 methyl, 4 methyl, 1 hexane. Rule number 7, list alphabetically. It is already alphabetically. E comes first, then M. Rule number 8 and 9, group similar branches. So there are similar branches, 4-methyl. These are similar branches. We will group them. So it will become 2-ethyl, 4,4-dimethyl, 1-hexene. Naming side chains. 3-methyl hexane. If you count the numbering, 3-methyl hexane. So the numbering will start from this side, and this is 4-ethyl 2,3-dimethyl heptane. This is 5-ethyl 2,4,6-trimethyl octane. Name the structures below. 3-ethyl 2-methyl pentane. So do you select the longest chain? 1, this carbon, number 2, number 3, and number 4, and number 5. And this is 3 is 3-ethyl, and this is 2 is 2-methyl. We will say 3-ethyl 2-methyl pentane. And the next structure is this one, which is 3-ethyl 1,5,5-trimethyl cyclohexene. So this is 1, 2, 3, 4, 5, and 6. We will start numbering from the double bond. Double bond gets the priority, and there is a methyl group at position 1. That's why we are writing 1. And there's another methyl group at position 5. That's why it's 5 again. And there is another methyl group at 5. That's why another 5. So that is 1, 1, 5. Trimethyl, because there are 3 methyls. That's why we are saying it's tri. And there is an ethyl group at position 3. That's why we are calling it ethyl. The name of the compound will be 3-ethyl 1,5,5-trimethyl cyclohexene. Why cyclo? Because it's cyclic in structure. Why hex? Because it contains 6 carbons. Why alkene? ENE, because it contains double bond. So that is a basic nomenclature of cyclic alkenes. More practice. So this is the 4-bromo 7-methyl 2-nonane. You count numbering from this position: 1, 2, 3, 4, 5, 6, 7, 8, and this is 9. So 4-bromo 7-methyl 2-nonane. Why? Because there is a bromo group at position 4, and there is double bond. That is why we are saying it ENE at the end. There are 9 carbons. That's why we are saying in non. And there is a methyl group at position 7. That's why we are saying it 7-methyl, and bromo at position 4. Can you guys name these two compounds? This one and this one. You try first, and then I will tell you the answers. Okay guys, let's give the name to this compound. This one, there are 2 double bonds, and there are substituents bromo and chloro. So we will start numbering from this position. So this is 1, 2, 3, 4, 5, 6, 7. So 2 and 4, 2, 5, 1, 2, 3, 4, 5. This is number 5. So 2, 5 dibromo because 2 bromines, and there's a chlorine at 6th position, so that is 6 chloro. 1, 3 because there is double bond at 1 and double bond at 3. We call it 1, 3 cycloheptadiene. Why cyclo? Because it's cyclic in structure. Why hepta? Because it contains 7 carbons. Why di? Because it contains 2 double bonds. Why ene? Because it contains double bond. How about the next one? The next is 5 fluoro. So if you do numbering from this position, 1, 2, 3, 4, 5, 6, 7, 8. So that will be 5 fluoro because there's a fluorine at 5 and there are 2 methyl groups at position 7. We will call them 7,7 dimethyl. So 7,7 dimethyl. 2, 4. There's a double bond at 2 and there's a double bond at 4. 2, 4 octadiene. Functional groups. This is a class. You should write these down. Functional groups. As you can see, this first compound contains OH group. That's why we call it alcohol. This is ROR. Oxygen is in middle of 2 R groups, that is ether. Aldehyde is this. Ketone is R group and both sides are R. This is R and this is R, then this is ketone. Carboxylic acid is this one. Ester, this one. Amine, this one. Now more practice. How will you name compound 1, 2, 3 and 4? Think about these 4 structures. You have few minutes to think, and then compound 1 is octane. Why? Because it's a long chain of 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. How about compound 2? It is 2,5-dimethyl octane. 1, 2, 3, 4, 5, 6, 7, 8. So this is 2, this one is 2, and this one is 5. So that's why we say it's 2,5-dimethyl, because it contains 8 carbons. That's why we say octane. Compound number 3 is 2,2-dimethyl-3-hexane. Why? Because if we say numbering from this position, 1, 2, 3, 4, 5, 6. So that is 2,2-dimethyl. There's a double bond at position 3 and there are 6 carbons. That's why we say it hex, and there is double bond, that's why we call it ene. So 2,2-dimethyl-3-hexane. Now this is a 5-member ring. As you can see, this will be the number 1 carbon, 2 and 3, 4, 5. So 1,3-diethyl cyclopentane. Why cyclopentane? Because it is a saturated compound, ANE. Why cyclo? Because it's cyclic in structure. Why 1,3-diethyl? Because there are 2 groups, two ethyl groups at 1 and 3 position. Can you guys name compound 5, 6, 7 and 8? Okay, so this is 4-nonene. Why 4-nonene? Because it contains 9 carbons if you count numbering, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and there's double bond at position 4, that's why we call it 4, and there are 9 carbons, that's why we call it non, and there's a double bond, that's why we say it in. This is cyclopropane. Why? Because it's cyclic in structure, prop because it contains 3 carbons, and ane because it does not contain any double or triple bond. Compound 7 is cyclic in structure, so it's 3,3-dimethyl cyclopentene. Why? Because 1, 2, 3, 4, 5, so 3,3-dimethyl cyclopentene. Cyclo because it's cyclic in structure, pent because it contains 5 carbons, and E and E because it contains double bond. 6-ethyl 2-octo-Y-ene, so this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. So this is 6-ethyl 2-octo-Y-ene. There's a triple bond at position 2, and there are total 8 carbons. That's why we are calling 6-ethyl 2-octo-Y-ene. How will you name compound 9, 10? 3-methyl hexane and 4-ethyl 2,3-dimethyl heptane. This is a compound 11. Name is 5-ethyl 2,4,6-trimethyl octane. If you don't understand the numbering of these compounds, put your comments below in this video. I'll try to explain the numbering of these compounds. Compound number 12, 13 and 14, 15. Easy nomenclature. This is cyclobutene. This is very famous. Compound 14 is benzene, and compound 12 is 3,4-diethyl 2-hexene, and compound 15 is 1,2-dimethyl 6-propyl cyclodecane. Again, if you do not understand the numbering of these carbon compounds, please let me know in the comment section, then I will explain the numbering. Compound 16, 2,7,8 trimethyl decane. We will start numbering from this end. We will end it here. So start S and end here. And next one is simple, straightforward, 2-hexene. Compound 18 is very simple. So 4-ethyl, we will start numbering from this one. 1, 2, 3, 4. So 4-ethyl 1,2-dimethyl cycloheptane. And compound 19 is 3,3-diethyl pentane. Compound 20 is 2-ethyl 3-methyl pentane. So it's easy. So you start numbering from this carbon. 1, 2, 3, 4 and 5. We have already done this. 3-ethyl 1,1,1,5,5 trimethyl cyclohexene, and that's the end of the nomenclature of practice of alkanes and cycloalkenes and alkenes as well. We touched a little bit alkynes as well. So we discussed in this video a nomenclature of alkanes, alkenes and alkynes, and if you have any further questions, please let me know in the comment section. Thanks for watching. Take care. Bye.